Boots the monkey. Do you like to explore? Me too. Today we're going on an adventure to Grandma's house for the Quinceañera de mi hermana. Yay! Yay! Hey, no, there's a monster in our path and he's making a whirlpool. Cannot get across.
That's okay, we'll just go around.
Yeah. Hey, no!
Yeah, buddy!
That's swiper. Swiper, no swiping. Everybody with me.
Swiper, no swiping.
Oh man! Help me! Help me!
I'm coming to save you, Boots.
Boring.
Well, it looks like the whirlpool is modeled by this function. And we all know that the work required is the integral of force vector function dot by the path because the work is the force times the distance. And we are summing up the distance of the path multiplied by the force from the vector field. Let's see which path will require the least amount of work. So let's assume Boots is located at 2, 4, which is the xy coordinates. So right here, 2, 4. And assume that Dora starts from the origin, which is 0, 0 at the center of the pool. So now the first path we're gonna consider is y equals to x squared. So we can parameterize this curve as t and t squared, where t is less than or equal to 2 and greater than or equal to 0. And so here is the work equation, which is force times distance. So we start off with T1, which is to T2, and then P and Q stands for the force field. Okay, so we are going to use the dot product of the force field PQ and R prime T, which is the derivative of T and T squared, which is also 1 and 2T. So here is the next step. So T squared negative T dot 1 and 2T becomes T squared minus 2T squared. You just add those two values up, and then now you do the integral of that, which is, okay, first you add it up, and then you do the integral, which is negative T cubed over 3, and then you evaluate 2 and 0. And you get the answer, which is negative 8 over 3, and the work done is in joules. So that's how much work Dora has to put into in order to get to that spot where Boots is from the origin. The second path we consider is a straight line, which is y equals to 2x. This curve can be parameterized as t and 2t, where t is less than 2 and greater than 0. So again, work equals to force times distance. And so 2t negative t is the force field, while 1 and 2 is the r prime t, which is right here, the derivative of rt. And then so we do the dot product, which is 2t minus 2t, and the result is actually 0. So if Dora follows this path, that means she doesn't have to do any work to get to where Boots is.
Great job.
The last path that we are going to consider is an elliptical path centered at 0 and 4. We can parameterize this elliptical path using polar coordinates. So x equals a sine t, a equals 2, so it would be 2 sine t, and y equals 4 minus 4 cosine t, and rt will equal to xy, which is 2 sine t, and 4 minus 4 cosine t. If we limit t to 0 to pi over 2, then we only get this part of the ellipsis. And so when we do the derivative of RT, we get 2 cosine t and 4 sine t. So now we do the dot product to find work. So work equals to force field times dot RT, R prime t, which is this. And then when you do, after you do the dot product, you get a cosine t minus a cosine squared t minus 8 sine squared t. And you use the trigonometry identity. You get a cosine t minus 8 dt. And when you do the integral of that, you get 8 minus 4 pi, which is approximately equal to negative 4.57 joules. Which means that in order for Dora to get to where Boots is, she has to use about 4.57 joules of energy. And so our conclusion is that the second pass, a straight line, y equals to 2x, requires the least energy for Dora and is therefore the easiest pass because it requires 0 amount of work.
Great job.
Math sucks. Math sucks. I'd like to burn this textbook. I hate this stuff so much. Math sucks. Math sucks. Sometimes I think that I don't know that much. But math sucks. I got so bored.